Hello all, welcome to the video lecture series for the subject compiler design. Now I am going to explain you all about the regular expression to DFA conversion. How does it happen with the direct method, right? So let me take you to the topic directly. So there is a procedure to be followed when a conversion of regular expression to DFA in a direct method. Say for example, it starts with syntax tree. Right, number one. So before doing any procedures, we need to have a syntax tree. And number two, it will have nullable. Right. And then we need to find first position. Right. And then we need to find last position. Right. And then we need to find follow position. So I'm going to explain in deep about all these four aspects, right? So generally we have some characteristics attribute for nullable, and then first position, last position, and follow position, right? So let me tell you how does it happens, right? And finally we are going to derive DFA for any given expression, right? Regular expression. Right. So now let me tell you how does this first position works, last position works, and follow position works. So it has some procedure to be followed, right? So now let me take you to the first position, right? Right. Now listen here carefully. When this first position deals with a nullable value called closure, assume that there is a nullable value called closure, right? You all know how does the closure works. Say for example, it have a value to be pointed as A. The first position of this, right? Assume that it is a node A. The first position of this nullable value, that is closure, is equal to first of A, because it doesn't have any values from closure to A, and A to closure will have the same value as output. This is number one, first position. So it is for asterisk. I am going to show you the same feature for plus, that is you can call it as an OR operation, right? Say for example, it have two nodes, that is say for example it is C1 and the C2, right? So now I am going to show you how procedure works for this plus, right? So here the first position of plus is equal to, we need to take, or in the sense we need to take both of this value. That means first position of C1 union first position of C2. That means it is going to be considered both the values by taking the union of it, right? So this is the future of OR. You all know about this very well because we are continuously working on this DFA factor, right? Let me take you to the dot. So this is what the basic you have to know, and how does the procedure works for the same kind of node, that is C1, and here it is C2, right? The same process, but the approach is different, right? The procedure, the same procedure we are going to apply, and we are going to find the regular expression to DFA by using a direct method, right? Here I am going to write a procedure, that is first position for this particular dot is equal to first position of C1. So this is the part. So it will always take the first value of any node, any two node you have that with a dot representation, right? So it will always take only the first value of this. It will always depends on this. Now say for example, if the condition, like if C1 is an epsilon, in this condition what to do? So this kind of scenario you need to look out. So in this kind of scenario, what it will do? So now it will do one more thing, that it will take the union of both. When these value, that is left side, that is first position of this dot is null, then it will take union of C1 and C2. That's it. So here you can see that first position is equal to when this particular C1 value is null. So that is the point. if C1 is null, then first position of C1 union first position of C2. This is how it works, right? So let me give you the same process. This is for first position. We need to look for last position and follow position 2. So there is a procedure and it is to be followed for first and last. If you understand the procedure for finding this first position, then it is very simple for you to derive any kind of regular expression given. Right, now I am going to explain you the same continuous process for last position, right? So for example, I'll start with the same thing, but I'm not going to use the diagram here because I have drawn that already. You can able to verify and rewind and see what exactly it is, right? So now I'm going to last position. So I'm going to show the same position, that is last position of nullable value called asterisk. Okay, so this is called, we used to call it as closure, right? So last position of this value is equal to last position of A. Initially we see that it is a first position of A in first position. In last position it will take the last position of A. So that is the only difference, right? All other things are same. Now I am going to do the same process, position number 1, position number 2. We are going to do this for dot now, dot, right? Or else I'll start with plus. So here last position of plus is equal to last position of C1 union last position of C2. The same thing, right? So there in first position we have seen first position of C1 and first position of C2, but here in last position the only difference is this: it will take the values in the last position of any given nodes. Number 3, so now I'm going to represent the dot value here. Last position of dot, how does it happen? So it is going to be the similar way, the same similar way, but it will take the last position value. Actually for this last position of dot is equal to, the value will be considered in this way, that is last position of C2. So this is what it will get, right? If there is a condition, right, if last position, that is C2 is null, right? So I am writing the condition here. If C2 is epsilon, that is null, then what I am supposed to do? So we know well, if this condition arrives, then we need to take union of this particular thing. So I'll rewrite this, I'll rewrite the same position. So last position of dot, when C2 is null, that means when we are finding the last position, so the procedure here, it is last position dot of dot is equal to last position of C2. But when it finds that this C2 is null, then last position of dot is equal to last position of C1 union last position of C2. So this is what you need to remember whenever you are finding any particular process, that particular thing which happens only on dot. You will never get any confusions on doing this nullable value, that is asterisk, closure, and this plus. Okay, so now I am going to show you what is nullable. All right, so let me tell you what is this nullable. So this nullable, this particular nullable will have two features. Either it can be a value, it can hold a value, or else this closure can have two approaches. That is, it can be either null or else with value. So in that particular condition, we need to take both. That means we need to take exactly the left and also the right, the possible ways we need to approach. So that is the only aspect you can see in this particular nullable values, right? So let me take you to the example where you can find how exactly the procedure works and how exactly the regular expression with any given approaches can be adapted, but we are using only the direct method, right?